Okay. So today is day two for business intelligence. I'm just repeating once more time what we have covered at the end. So just like we have learned a SQL part over there, we are creating multiple tables and all. Okay. But while creating the dimension table or fact table, I mean the data mart table should be either dimension table or that can be fact table. So that decision we need to take in the fact table, which are the columns name, what column names need to be kept there, and in dimension table, each of the dimension table, what should be the dimensions. Okay, let me repeat once more time. Fact means in fact table, fact data should be there. What is fact? Facts answer the questions of how much or how many. So the answer should be numerical in nature, especially. There can be non-numerical data of fact too, but in general scenario, we should be having numerical data answering those questions. So those are the facts: revenue, cost, number of accounts, just for an example. So when we are keeping those columns over here, just like sales tables is a fact table, billing table is a fact table. In billing table, you can see all those top four columns are foreign key. There's a date key, customer key. So date key for each of the foreign keys, located over here just to set relationship between each dimension table. So there is a date dimension table. In the date dimension table, maybe date dimension table is here. So date dimension table, date key should be the primary key, and we are setting date key over here as a foreign key. So that when we can create data modeling, we can set up relationship between fact and dimension. We can fetch data for the correct value. It's just like customer key. Customer key means a customer ID should be there. Okay. But when we receive, when we need to know the current or original data of customers, then what we should to do, what we should have to do, based on customer key, we can join between customer table and we need to fetch all the customer related information. Maybe customer first name, last name, their addresses and all. Service line key. There is service line table, dimension table should be there. Just like same. The top keys columns are foreign key in the fact table, and the below section, those are the main facts. Okay, you can see number of total minutes, number of calls, service charges, taxes. So those are facts. Okay. So fact table consists of the foreign keys and those original facts. Similarly, dimension I have mentioned earlier. If we question on top of data who, what, when, where, the particular answers we are getting over there, those are dimension table. So different types of dimensions are here. Just like two examples I have provided, store and product. In product, all the product related information should be there. Okay, product key, product ID, product name, product group, brand, department. Now you can think about it. Store is a dimension also. So store key, store name, a street address, city, state, region, country. Now you can think the dimension is very slow changing in nature because maybe I am the owner of the company. I have a plant. Each of the product, I am giving a name, product ID, product name, product group, brand, department. So maybe the scenario is this. Maybe last 1 month or 2 month, I haven't introduced a new product. New product. If I have introduced a new product, then that should be entered in the source table system or source database. Okay, and the new product key should be generated against that product. But dimensions are very slow changing in nature. Okay, just like store saves all the store related information. I am the owner of that particular industry. I have multiple outlets in multiple cities. So which particular outlet is having which address, which name, which address, the city, state, region, and country. Okay, so maybe the scenario is I'm not launching daily basis a particular store. Maybe in 1 year, the store data is fixed. Again, in the next year, I have launched one new store and the new data has been inserted in the source table. The same thing we can pull at the dimension table too. Okay, so dimensions are very slow changing in nature. I'll be coming with dimensions, slow changing things quickly. Let me come to fact first. But fact is the main transactional data. Fact is storing the main transactional data. In each store, what are the transaction in second or in minutes? The transactions data mainly is stored in fact table because there are how many rupees the particular product has been sold by that particular customers. Okay. So this kind of stuffs we are entering in the fact table within second based on the frequency of the product purchase. Okay. So just to give you an hint, fact tables are loaded very frequently or refreshed. Data can be refreshed in fact table very frequently rather than dimension table. Dimension tables are very slow changing. We'll be learning slow changing dimension within few minutes. Just give you an, I'm going to give you this concept that fact tables are getting refreshed. Whatever transactional data is there at the source system, those are being kept in fact table specially. So that's why facts are being refreshed very quickly, but dimensions are refreshed very slowly. Okay, give me 1 second. Okay, any issue till now from anyone? Any issue? Okay, I hope no. Coming to the fact table. So those are some terminologies. So when you are expert, maybe you are working as a data analyst team. So there you need to, after population of the data at the data warehouse, you need to create the fact and dimension table properly. Maybe you have an architecture in your team. He or she can tell you what should be the columns you need to keep in the fact table. First of all, they need to determine how many fact tables should be there, how many dimensions tables should be there. Okay. And in each of the fact table, what are the columns? Even a developer can also think about it, but that should be experienced one. But if an architect is there in your team, they can determine what should be the fact table and what should be the dimension tables, DDL. Not DDL exactly, the column names. Developer should be creating the DDLs almost. But what should be the columns present should in the fact table and dimension table, that can be determined. Okay. In while determining the fact tables data, we can face this kind of terminology, grain and granularity for fact table only. So grain means in a table, a single row signifies what particular thing, that is called the grain. Okay. Giving you in an example. So this is a fact table. It's having sales ID, bill number, date, item code, store ID. Till these columns, those are particular foreign key to set up relationship between dimensions. Okay. And those two are fact table. Fact information. It's been kept in this fact table. So what is the granularity? Sorry, what is the grain of this fact table? Sales transaction per item in a bill. So one particular row signifies this kind of thing. Sales transaction per item in a bill. Okay. Moving to another example. So this is another example. We are having year, batch, exam name, student name, subject, marks. Over there, uh, what should be the grain? Marks of a student got in a subject in an exam. This is the grain. Means a particular row is signifying what thing in the fact. So this is called grain. One liner representation of the entire fact table, so that maybe sometimes architect can tell you only the grain. You need to determine what particular columns you need to put, or you need to design the entire fact table definition. When that is ready, then you can go ahead with creating the DDL statement. Create table, table name, the different column names, their data types and all, and you can create the fact table. Okay. Now, what is granularity? Granularity means how much line items you want to push into the in a particular row. Okay, so how much detailing level data? Granularity refers to the level of details of data stored in fact table in a data warehouse. High granularity refers to the data that is at or near the transaction level. In the transaction level, it's the highest granularity. Data that is at the transaction level is usually referred to as atomic level data, and low granularity refers to the data that is summarized or aggregated. Okay, okay, let me go to this example too. So this is a fact table. He's having the grain marks of a student got in subject in an exam. Okay, over there you can see uh, for a student just like Aryan Dev. Aryan Dev is mentioned 3 times over here. Why? Because there are different subject. For based on different subjects, marks are splitted. Even you can see this is the mid-year exam for Aryan. Mid-year exams are there too. Let's omit the column subject. If we omit the column subject from this table, the grade should be updated also. Marks of a student in an exam. Okay, that should be the grain. Even the granularity should be updated too. If we remove subject, there is no meaning of specifying these two different line items. Okay, so 2013 is fine, 9B is fine. Finals, no two exam names should be there. So we need to keep this thing merged. One finals for Aryan Dev. Physics and maths, we can add these 2 marks, 50 and 98, and we can put the marks, aggregated marks, the summation of the marks over here. Okay, so these two row can be merged if we omit the subject, because we don't want to split the entire fact data based on different subjects. Okay, even we remove the exam too, then we can also merge these 3 row. Just we need to know for a particular year, a particular batch, a particular student's marks. Okay, the grade should be also updated. In an exam should not be there, and the granularity should be also updated. We have to aggregate these 3 marks and put it in a single cell. Instead of having these 5 rows, there should be only 3 rows. So it's very low granularity. Sorry, yeah, I'm correct. So very low granularity is there. If it is very high level, then it should be splitted into multiple line items. Okay. Is it understandable what I'm telling? A bit complex in nature, but if you are understanding it, that should be very much interesting. Grain and granularity. Any doubt from anyone? So just a simple fundamental concept. If we want to have, we want to check the data with more granular level, the more line items should be there. Even we can make it more granular from here too. We can add maybe question type, a different column name. Okay, so maybe broad question and short question, or maybe section wise I'm differentiating the marks. Then there should be another line items. 2013 9B finals Aryan Dev physics. Then section A, the number should be splitted. For section A, it should be 10. For section B, this kind of row should be there again. For section B, it should be 10 again. So this way, it's much more granular again. I'm introducing a new columns. So based on the new columns, the row can be splitted. So the data should be more transaction level. It can be told as atomic level too. Okay. So that is the thing. What is granularity means? It's also impacting the grains. So if we just introduce new columns, granularity can be updated with the grain. Okay. Okay. If there is no doubt, I'm moving to the next slide. Yes. Now it's time for dimension. I mentioned dimensions are very slow changing in nature. So for for maintaining dimensions, we can follow this kind of designing strategy. Slow changing dimension. In short form, they are told slowly changing dimension (SCD). And the dimension table can be designed in either of these three. We are having specifically some more constraint imposed on top of each of the SCD type. SCD type 1, type 2, type 3. Each of the type 3 should be having some extra features. Type 2 is having some features. Type 1 is having some features. We'll be going to this feature. I have an Excel over here. SCD example. I have already opened it. Yeah. Okay. Let's check into there, into that table. Okay. So it's a dimension table. The dimension table is employee. Employee related information is being stored over here. Okay. So this is an example of SCD type 1. So what is the thing? We have, for a particular company, we have 4 employees. Okay. Employee ID 1, 2, 3, 4. With those are the employee names. Okay. Employee designations are there. Okay. So this is the employee tables data. Tomorrow, maybe tomorrow something has been updated at the employee. Maybe a new employee has been joined. Maybe an existing employee's designation has been updated. Anything could be happened to this employee table. So next day when the source systems table has been updated, the OLTP that I was mentioning earlier, OLTP is updated, then our ETL should be also running and it should capture the updated records and it should keep inserting the new records into data warehouse or data marts. So the next day we received a new records for employee ID 5. A new employee has been joined in the company. So it's in previous day. So the next day the new records has been loaded through ETL tool 5. Along with that stuffs, we can see employee ID 1, his designation, his or her designation has been updated from training to developer. Okay, so we are mentioning there are 2 updates. There are no more updates. Those are same. Those 3 columns are same over here and here too. One update, trainee has been updated to developer, and one update over here. A new employee has been joined as trainee. 5 DER. His name is DER. Okay, it's a just a small, naming convention. That's it. And employee designation is trainee. So this is this if we maintain this way to store dimension data, that is called slowly changing dimension type 1, SCD type 1. There is few of the drawbacks over here in these methods. What are the drawbacks? Maybe there are some analysts, they want to check the employees, the transition date, a particular date when the particular employee has been transitioned from a particular designation to another designation. Maybe based on that date, they are expecting the next promotion properly. Maybe based on that date, they are checking a probability to for the particular employee to leave the company, to resign from the company. Okay, there are lots of things needed to be stored or to calculate the data to get the proper output. Okay, what are the things? Okay, here it comes the ACD type 2. We are introducing a new column date to get the transition date for a particular employee. Just like trainee has been updated to developer, but we do not have any information which particular date that particular things happens. Okay, so over there, if we have this kind of data in the source side, I'm including the date too. Date means which particular date the trainee designation, the particular employee received the trainee designation. It should be obviously joining date. But the account manager, which particular date that particular employee has been promoted to account manager? It's this date. This is the date for developer. This is the date for senior developer for this particular employee. Okay. So if we have a new record, suppose ABC has been promoted from trainee to developer in the very next day. Last 1 year he was trainee, and today 1 year has been completed. So the transition should be there from trainee to developer. So you can see 23rd Jan 2022 he was trainee, and after 2 days data load, we can find one ABC developer. Again, I'm mentioning this column. Rather, I'm not updating in the same row. I'm updating in a different row because the date is different. This is transition date. Rather, let me put it transition date. Okay. So just sorry. So just to let you know, we are introducing this column to have some historical information. So ACD type 2 it's storing the historical data based on the date key. Okay, we have the historical information which particular employee has been designated at which particular date. Okay, based on that, based on their performance, we can prepone the promotion, we can postpone the promotion too. Okay, so that's why this particular column has been introduced in SCD type 2. Now, what is the scenario for SCD type 3? You can see the data over here. We are not introducing a new columns over here. Sorry, new columns means on a new row over here. Rather, we are mentioning in this way: employee ID, employee name, employee designation. This is the transition date and this is the previous designation. I'm introducing a new columns over here again. In this scenario, we are not maintaining an extra records over here. Rather, in the same record, we are maintaining this thing. Previous designation or previous designation date. I can put. Okay, I can put another extra row. Previous designation transition. There are two extra columns I have introduced. Comparing to ACD type 2 and type 3, type 2 should be having much number of rows. Okay. But over here, we are not introducing more rows. Rather, we have introduced some more columns where we can maintain the history with more efficient way. Okay. We can maintain any one of this. Okay. This is the example of ACD type 3. Okay. Any doubt from anyone? No doubt. So this can be questioned in the interview. What is SCD type 1, type 2, type 3? So maybe they can give you the scenario, they can tell you which kind of storing methodology you will be trying to do. SCD type 1, type 2, type 3. Which do you think is the best scenarios to do? And they can ask some interview questions on top of this thing. What is SCD type 2, type 3 and all. Okay. So you can keep some notes on top of that. You can get the topic from the web too. But if there is any stuck point, kindly ask me questions. Moving to the next slide. Okay. So this is called the data modeling. Data modeling, uh, when our fact and dimension tables are ready. Okay. Our fact table. So this is the fact table. And those are the surrounded dimension table. In the dimension table, there are product dimension, customer dimension, register dimension, promotion dimension, clerk dimension, store dimension, time dimension. So we have the foreign key. Each of the dimensions, we are having one foreign key in the fact table that I mentioned earlier to set up the relationship. So we are setting up relationship and getting the data from this table to this table. Okay. So when our fact and dimensions are ready, we can create those data modeling. Even it's a top-down approach too. We need to create the data modeling first. Just give me 1 second. Ah, sorry for that. So uh, it's a top-down approach. Actually, architecture are first designing the dimension, the data modeling first. So when the data modeling is ready, they can instruct you or instruct the new developers to create the fact and dimension in this manner. So fact should be having this column. I mean the dimension should be having this column. They have the blueprint of the data modeling. Then they can transfer this thing to new resources for developing fact and dimension table. So when facts and dimension are there, we can check the data modeling. We can test the data modeling whether it's working properly or not. It's not only this relationship, we need to also think about the cardinality. What is cardinality? Okay, let me tell you the thing over here. Cardinality means maybe for a particular, when we are joining between two tables, we need to think the one-to-one, one-to-many mapping relationship between each table. So just we have to think for this product key, okay, if we are checking from dimension to fact, for this product key, there should be multiple records over here because a particular product can be sold or can be purchased by multiple users in the store. So against this product ID, there should be multiple product ID present over here. Am I clear? Because this product ID can be repeated over here because different transaction. Over here, product ID should be only single because each of the product can be represented by each of the products. So we need to set up proper cardinality. So here, dimension to fact relationship should be one to many based on product key. Especially this should be the thing from dimension to fact. One to many should be there, but there are few of the examples should be also there. There should be one to one, or especially for some of the scenarios. If we are checking from dimension to fact, for complexity of the data modeling, there is snowflake schema. Okay, let me come what is schema. So based on different data modeling, we are segregating the data modeling part maybe in star schema, and another one is snowflake schema. So this is the coordination of star schema. In star schema, there should be a single fact table and multiple dimension table. Okay, and the fact table should be having surrounded by these dimensions. Okay, just like sales fact table, and there are different dimensions. It's looking like a star over here. So there it means each of the dimension should be having one foreign key saved in sales table. Okay, then it can be formed a star. It's called star schema. Okay, this is fact table. Those are dimension table. Now, what is snowflake schema? Let me show you an example. Then we'll be covering this thing. So in snowflake schema, you can see there is fact table. Those dimensions are similar kind of stuff, just like star. But you can see this brand, category, those kind of table are not directly tagged with fact table. Rather, we are creating this dimension product. On top of the product, we are splitting into different dimensions. Based on brand, I'm creating a separate dimensions over here. Here, brand is not directly tagged with this fact table. Brand is tagged with the product table. Okay. So based on our requirement, based on the architecture, we need to determine what kind of data modeling we need to follow. Whether it's a star schema or whether it's a snowflake one. Star is the simple one. If you have all the keys ready in your fact table for each of the dimension, you can go ahead with the star. But in practical scenario, there is not 5-6 tables to be incorporated in the data mart or data modeling. There are maybe 40-50 tables are there to create a data model. Over there, it's very hard to accommodate all the foreign keys in a particular fact table. And there is no necessity of this thing too. Maybe a dimension should be having very less numbers of rows. So we should not have to introduce a primary key there to be accommodated in a foreign key way in fact table. So in this kind of scenario, we can choose this snowflake modeling. It's a bit complex but useful in nature. Okay. Any doubt from anyone till now? So the question may arise is what is snowflake schema? What is star schema? What is the difference between these two? So be prepared for that thing if you are going to give an interview or anything. It is very important question and that can be definitely asked. Okay. Okay. So we have covered dimension and fact and how we are creating data modeling. When data modeling is ready, we can hand over this entire stuff to our visualization team. Visualization team can create charts and graphs on top of these data mart tables. Okay. Now I'll be coming to the visualization thing quickly. Before that, I'll be covering something on top of ETL. So ETL I mentioned yesterday. ETL is a job or a set of batch jobs which will be running daily basis. Or if the data is very much critical, then we can also run the ETL jobs maybe hourly basis in a day. So based on the criticality, the ETL batch job runs and it will pick up the new records or the records from the source system and push it to data warehouse that we mentioned yesterday with the flowcharts and all. So ETL is a tool or its batch jobs which will help to populate the data from source system to the target. Okay. So if ETL, it's an abbreviation. E means extract, T means transform, L means load. Extract from the source system. Okay. Transform means in between there, what kind of data we need to store at the data mart, what different logic we need to implement there, that is coming inside transformation. So extract, transform, I'll be transforming the data and loading this data at the output. Output means our target table. Target table is our data warehouse table. Okay. So operational system is OLTP that I mentioned it. It's our source system. So those are the various kind of stuffs. We are capturing the data means we are extracting the data. We're applying some data cleansing quality. I mean, we are cleaning the data. Maybe there are some white spaces there available. Some NAS values are available. Lots of duplicates data are there in the source system. We are removing that stuff too. We are transforming the data based on our business rules. Okay. And finally, we are storing the data in enterprise data warehouse. Okay. Then we can push it to data mart again from data warehouse. Okay. Now, some brief ideas on top of data extracting method. How we can extract data from the source system. So there are things we can go ahead. One is full refresh, one is incremental data load. So what is the difference between these two? Full refresh means if we want to have a full refresh of the source table to target, then we can go ahead with these steps. But in efficient manner, suppose in the source system, maybe we are working in a banking sector over here. So in a bank, each day there are lakhs of transaction. Okay, for a particular branch, I'm telling, or maybe not a particular branch, for a particular bank, there are lakhs of transaction. So each day we will not be loading all the data. Then each day you can see the source system data can be appended. So today it's 1 lakhs, tomorrow it should be 2 lakhs, the day after tomorrow it should be 3 lakhs. So when we are loading the data from source system to target, if we are doing the full refresh, the performance will be very, very slow. So maybe after 10 days, after the bank has been inaugurated, you can see 10 lakhs data are there. So if you are go ahead with 10 lakhs data to be full refresh means we are cleaning the target table, we are truncating the target table, and we are copying all the data from the source system to target system. If this is the scenario, then data should not be, I mean, it will take lots of time to refresh the data. So this is the concept of full refresh. Means we will be taking all the things from the source system and pasting the same thing at the target. Deleting it, what it was there earlier at the target, will be copying the entire stuff from the source system and pushing it to target. But to remove the performance issue of this thing, we can introduce incremental data load. What is incremental data load? So we'll be checking what are the new data. We'll not be deleting any records at the target table. We'll be taking the source data and we'll be checking what are the new records that has been populated for today only. Because yesterday's data, till yesterday's data, those are already present in data warehouse. No need to pull these records again. We'll be only pulling the new records. So in the source system, there might be some flag column or maybe some date column should be there. So in our ETL system, when previous day's load is there completed, we can capture our ETL timestamp and we can capture the source table timestamp. We can check till what rows we have populated or processed till last processing time of ETL. And we can compare the same thing in the previous, I mean the next day when running the jobs, the ETL jobs, we can compare what are the new records comes based on those timestamp, and those records should be pushed into the target. That is called incremental data load. We are not taking all the things at a single go. Rather, we can check what are the new records that comes and we can load only these records or we can extract only these records. So this is extracting method. Now I'll be mentioning the loading strategy. So just like it's similar, for full refresh, we need to truncate and load. If we just go ahead with the full refresh, then the target table should be truncated first. That means truncate table name, and we'll be pushing all the records from source system to target. Okay. Now, if we go ahead with incremental data load, if we just go ahead with this thing, then we can go ahead in either way. Either we can go ahead with insert. So whatever new records we are receiving, we can insert it. Okay. And we can go ahead with update and insert method. That means it is in short form, it is also called upsert. Update and insert, it is in short form, it's called upsert. Okay. So maybe in incremental data load, we can find some of the existing record has been updated. And no such, new primary key has been introduced in a particular table. But okay, while doing this insert or incremental data load, we need to check based on the primary key. What new primary keys has been introduced over here. So if a new primary key is been introduced, that means new records has been updated, then we can go ahead with insert only. Okay. Now if we can see if an existing primary key, what it was already existing at the previous days, some record has been updated. Some of the columns data has been updated. Just like what we are learning in SCD type 1, there we can check the designation has been updated from trainee to developer. So for this kind of scenario, that will be updated. So that is upsert logic. It will be checking at the source system for the cases of incremental data load especially, what particular new records are updated in nature and what particular new records are incremental in nature, inserted in nature. So the new record should be inserted and the old updated record should be updated. So the whole logic is called upsert, and this is the modern one we need to follow. And our data should be correct while loading from source system to target. Okay. Any doubt from anyone related to this data loading strategy and data extracting strategy? Those are very, very important concept. Please try to note it anywhere and try to, yeah.
Nalvi, can you explain these two topics with a small example?
Yeah, sure. Let me open an Excel.
Okay.
Give me 1 second. I'm not able to, yeah. Excuse me. I'm suffering for some cold. Okay. I'm opening an Excel. Okay, let me take this
Okay.
data only. Let me take this data. So please be careful, everyone. It's very simple example. So suppose yesterday, this is first. Okay, maybe this is 31st over here. I'm taking 31st May. In 31st May, we have in employee table, this is the source system data at the employee table. So this is source system. Let me put, this is target system. As of now, I'm just neglecting the transformation as of now. I'll be just concentrating on extract and load. Okay. So 31st May, we have this data. What I have told, 31st May at the night time, non-business hours, the data will be refreshed for the entire day. At the end of the entire day, this is the data. At the night time, non-business hours, when we will be loading the data at the target system, target data warehouse. So if we just go ahead with a full refresh, then what it will do, it will be truncating all the target tables and it will be pushing what is there at the source system. It will be pushing the same thing at the target. This is full refresh and truncate load at the load side. If we just choose full refresh, obviously we need to choose truncate load at loading perspective. Okay, this is 31st May, or I can tell 1st June morning data at TW. Okay, so 1st June morning data, I'm capturing the same thing. Okay, so this is simple. I'm repeating once more time. Full refresh of table. It's very simple, but it's very much time consuming. When the day passes, there should be more records at the source system, and all the things should be appended over here by truncating the target table. Now, if we introduce the incremental data load, we need to introduce a new column. Suppose date time. Okay, so those are the new record for 31st May. Okay, let me just complete one more thing. For full refresh again, if we just check, this is 1st June. Okay, just give me one. Okay, uh, I didn't complete it. For 1st June, if we have this record, if we want to truncate load and full refresh, again, the entire thing will be truncated. Entire thing will be copied. It will be truncated from here and it will be copied to here. Okay. So full refresh is for full refresh from source system to target. We need to truncate the table and load the data. This concept is clear to everyone, correct? I hope yes, because this is very simple.
Yes. Yes.
Yeah. Now I'm moving with the incremental data load. For incremental data load, there should be an extra column, date time. So we need to capture in which time the particular designation has been updated. Okay, or which time the row has been generated or inserted in the source table. Rather, I can say create date timestamp or create timestamp, create TS. So maybe it's been updated 31st May. Okay, let me follow my SQL rule. It should be 2023 31st, not 31st 05, then 31st. Then let me put the timestamp 8 AM EST 8 8. Let me put 8 AM only as of now. It's not proper time format. Let me update it all the records. Maybe in the same day it has been updated at 10 AM. This has been updated also at 10 AM. This has been updated 11 AM. Okay. So our ETL jobs runs at the night time, maybe uh, 11 PM EST. Okay. So when it runs, it will check it is having okay, that thing should be also there too. First of all, we do not have these records. Okay, so first day this has been done, but on the second day we have this new records, or maybe not second day, at the night time before the ETL loads has been started, a new record has been inserted over here. So maybe it's the same thing. Sorry. Maybe it's 11 PM. And this thing also, from trainee to developer, that record has been updated. So I'm updating the create timestamp. Maybe it's 6 1. Okay. So when our ETL job will run at the very next day, okay, in ETL, we need to configure the ETL such a way that it will store which particular timestamp last day the ETL data was being fetched. So it can store a timestamp when the ETL ran and what is the timestamp it fetched the data. It's been stored in the ETL system. So when the very next day, when the ETL will process, it will compare that timestamp with this timestamp. It will be checking what are the new records. It will be checking. Suppose in ETL, the cutoff timestamp was 10 p.m. So this particular time has been stored in ETL that I have loaded the data till this time. So it will be checking in the very next day what are the new records come. It will be checking this one because it is greater than the previous date and this one. So while doing the incremental data load, it will not taking into consideration these columns. Okay, it will be taking into consideration only this and this in 1st June. When the job will be running at 1st June night time, then it will be only taking these two records. It will not be bothering about these three. Okay, so only these two rows will be coming over here. Now we can go ahead in either way. It can be insert or append. Any mode, insert and append mode is similar. Insert means we'll be inserting the records. We will not be checking what are the things. We'll be only inserting the thing. So it's one ABC developer. Okay, it was one ABC training. Let me copy this thing first over here. Okay, it will not be checking what are the data. It will be just inserting the records. So it will be receiving two new records. So it will be inserting it over here. So this is a loading strategy. Okay, but we need to be careful. For this kind of scenario, I cannot declare employee ID as a primary key, only one, because for insert method, the employee ID can be duplicated. Okay, you can see over here. Now the concept should be coming as upsert, update and insert. So the same two records should be coming over here. It will be comparing the primary key. There we need to must have a primary key. If the employee ID is only the primary key, it will be checking on the employee ID for the upsert method and it will find this is the new record compared to last one. Okay. Okay, Pratus, I think your video is open. So when this particular new key has been generated, so it will be inserting it. Okay, and it will check for that primary key. It's not a new one. It's already existing at the target side, but the data has been updated from trainee to developer. So it will be updated over here. Okay, with the updated timestamp. So this is the upsert data loading strategy. Update and insert. We are inserting new records and we are updating the existing records which are updated from the source system. Those are the two data loading strategy. Any doubt from anyone? Is it clear now or still have some doubt?
It's clear now.
Okay, fine. So if you are a developer, especially on the ETL side, okay, you need to, based on the scenario, you need to choose what kind of data loading strategy you need to follow. Okay. Now, if you want to build your career as a ETL developer, those are the different products. Those are available ETL tools in the market. Just like it's called Informatica Power Center. Vendor name is Informatica. The product is Power Center. In IBM, there are data stage. Ab Initio, there is a product. For SAP, there is a separate ETL tool. For Microsoft, there is SSIS, DTS, Data Transformation Service. For Oracle, Oracle Data Warehouse Builder is there. So lots of, in Talent, there are Talent Studio. This is another example. So those are available tool which can be used for developing the ETL tool. But nowadays it's a trend. They're not using, the companies not, they're not using directly ETL tool because it's having a high licensing cost. Okay. So they're creating their own ETL tool. Each of the company, they're taking into consideration Python, Java, and on top of this language, they're creating some frameworks. Okay. And those are some ETL frameworks. So they're not taking any conventional ETL tool from here. They're taking into consideration some open sources languages, and based on that language, they're creating some frameworks, and they're loading the data from source to target by those frameworks. Those are also ETL tools, but those are not ready-made available ETL tools from the market. Each of the company, they're creating their own ETL tool by those languages. Okay. So in the next topic, when we'll be learning Python, we'll be learning Python, how a Python can be read the data from source system and push it at the target. And it can also do some transformation at the between. So we'll be using Python as a ETL tool in the next day's chapters when we'll be learning Python. Okay. Hope concept is
Okay.
clear. Now I'm moving to some of the concept on top of visualization. I think it's already over for today. Okay, let's connect tomorrow with the rest of the things, the visualization part. There are a few slides, and then I'll start the Python classes too from tomorrow onwards. So till today, we have covered the data modeling and the ETL part. Hope the concept is clear. Tomorrow, we'll be checking with the visualization part some important, just like KPI. What is KPI? Key performance indicators. Some terminologies on top of this part, this kind of stuffs. Okay. Okay. Then let's connect tomorrow. Any doubt for today's session? Anything?
No, Nandi. Actually, I tried working on the exercise too for the sequel.
Mm-hmm.
For the second question, like I tried to create one join for the three tables, but I
Okay.
couldn't get the proper output. Maybe we can look into it tomorrow.
Yeah. Tomorrow or day after tomorrow, we'll be trying to solve it out. I'll be
Okay.
requesting everyone to solve it. Soumya, Sammy, Pradeep, did you receive the exercise? I think no. So
No.
yeah, Pratyusha, it's good. I mean, you are solving it. Uh, it's very good, very good. Just try it. It is very fun actually. It's you can learn the things, and I'll be requesting everyone to solve this. I'm pasting this thing once more to everyone. Maybe you are not there at that day. I think Soumya and Pratyusha, you are the only one. So exercise
Yeah,
2, I think, not exercise 1. Exercise 1.
I think it's two.
It's 2. Let me open this. No. In exercise 1 document, the second exercise we are yet to be covered. Okay.
Okay, okay.
The first one we have covered in one of our classes. SQL 4. Fourth, I think we have learned. Yeah. Yeah.
Yeah, this
So,
is the one.
yeah, first one has already covered. This is some sample data. Open the sample data and try to. It's already been covered. You can try, whoever it's not completed, please try this thing at your home. I'm not just doing the advertisement. Don't try this at home. Please try this at home. And the second one, Pratyusha is telling. So I think Soumya is also doing. So we can cover up this thing on maybe tomorrow or the day after tomorrow, I'll be checking your answers and your maybe methodology, not exactly answer, how you are approaching, and if there is any stuck point, we can quickly cover this thing. It's very simple and the basic steps to be a data engineer. So, and it's also fun. There is not very hard things over here. Please try this thing at your own. We'll connect for that one maybe tomorrow or the day after tomorrow with some free time. So tomorrow the plan is I'll be covering up the rest of the slides for this one, and I'll be starting Python. Okay, Python
Okay.
basic introduction, and for Python beginning of Python classes, maybe 1 or 2 days it should be very basics, and after that we'll be using Python as a data engineer's tool. Okay, so we'll be creating data frames on top of. I mean, we'll be using pandas. We'll be creating data frames. We can use the transformations and all. And after that, we will be using Python as a ETL tool. I think Soumya, I
Okay.
think you already joined in previous classes and you learned Python, correct? Directly. SQL, you already, I mean, you missed classes for SQL. But yeah, if there is any doubt, you can still
Yeah.
there. But I hope you have already the experience on top of that, what you have covered in last classes. Okay. Okay, then let's connect tomorrow. Thank you, everyone. Bye bye.
Thank you.
Thank you.
Bye
Okay,
bye.
thank you.
Bye bye bye. Good night.